Okay, class. One more section of this lesson. What I wanted to talk about is really the benefits of standard form, right? Some of you may be wondering, why do we need a standard form? What are the benefits? I thought slope-intercept form was simple enough. Why are we learning another form? Okay, so let's go ahead and hopefully we can answer your questions by um, answering this problem. Okay, so first off, notice how we have the x and the y on the same side. All of the coefficients are integers, and obviously the constant is an integer as well. And the a value here is positive. So we know it's in standard form. Right off the bat, you can immediately identify a very, very nice perk of standard form, which is identifying the y or the x and the y-intercept, right? In order to calculate the x-intercept, remember that your y value must be 0. And if your y value is 0, you essentially can just block out the y and solve for x. Does everyone see that x is going to equal 10 in this case? Right? So my x-intercept is going to be 10 comma 0. Now, the y-intercept is not as easy to solve for, but it's still pretty easy. The y-intercept class is when x is equal to 0, and now I get negative 5y is equal to 10, right? Notice how my left index finger is blocking out the x because that means the x is 0. So negative 5y is equal to 10 is an easy solve for us, and we get y is equal to negative 2. So the benefit of having something in standard form is that you can easily solve for both the x and the y intercepts, right? Obviously, in slope-intercept form, the y-intercept was given. It was the constant at the end, the b value. But it's actually hard to calculate the x-intercept when something is in standard or in slope-intercept form. Now, having the two intercepts is actually pretty easy to graph too. If you just graph 10 comma 0 and then 0 negative 2, you can already see that I have 2 points of my line. And now all I need to do is connect the 2 points, make sure it's very, very straight. And once I connect the points, that's my equation, or that's my graph, right? You can see that the slope is rise of 1, run of 5, rise of 1, run of 5, or even rise of 2 and run of 10. Okay, but let's prove that algebraically. So x minus 5y is equal to 10. I now want to convert this to slope-intercept form. So I'm going to first subtract x from both sides. I get negative 5y is equal to negative x plus 10. Notice how you always want to put the negative x or whatever x value you have in the front of your right side, or in the front of your expression on the right side, because we always want the slope as the first value, right? Negative 1 divided by negative 5 ends up being a positive 1/5 x. And then 10 divided by negative 5 is negative 2. You can see that does match what we've shown on the graph. A 1/5 is the slope, and 0, negative 2 is my y-intercept. Does the equation in slope-intercept form represent the same line as x minus 5y equals 10? So essentially, they're asking, are these two representing the same situation? Yes. Both equations have a slope of 1/5 and a y-intercept of 0, negative 2. Right? The whole point of standard form, the whole point of this lesson is to show you that there is another form that exists. It can be more useful. And finally, you can always convert from standard form to slope-intercept form and vice versa. Okay, that is a skill you need to know. Okay. All right. I think that is all for now. We do have another page after this, but I'm going to leave that for you to practice. I just wanted to show a quick video of how to convert from standard form to slope intercept form, and obviously that is a skill you will need to be able to conduct in a quick and constant way. You got to do it all the time. So hopefully you get used to it after this lesson. Thanks for watching.